Hello, welcome back. We're going to do 6.2 today, which is all about the law of cosines, okay? Um, you might see my dog's head move right behind me. He's cuddling up right next to me. So we are doing the law of cosines today, which is another method that we can use in non-right triangles, so those oblique triangles. So 3 objectives for today. We're going to use the law of cosines to solve oblique triangles. Okay, then we're going to use the law of cosines to model and solve real life problems. And then we're going to use Heron's formula to find the area of triangles. So another method to find the area. Okay, so let's look. Again, we're not going to derive the law of cosines ourselves. We're just going to come down here to this guy. Okay, right here. So this is going to be the law of cosines. Okay, so in order to use the law of cosines, you either need to know all 3 sides, or you need to know side angle side. So if you know an angle and the side across from the angle, you're probably going to use law of sines. If you don't know an angle and a side across from the angle, you're going to probably use law of cosines. Okay, and then these 3 are the formulas that we're using. So notice that my whatever angle is in the cosine, that is what side is on the opposite side of the equal sign. And then your other 2 sides just fill in. So we are going to use these formulas to find or to solve triangles, right? To find all of the different pieces of our triangles. So let's go down and look at example 1. So example 1 says find the 3 angles of a triangle in which, and I'm going to go ahead and label, in which side A is 8, side B is 19, and side C is 14. So typically, what you want to do is find the largest first. So find the largest angle first. We know which angle is going to be the largest because it's across from the largest side, right? So here angle B is going to be the largest. So we're going to use our B squared is equal to A squared plus C squared minus 2AC times cosine of B. So this is the one that we're going to use because I want to find angle B. I'm trying to solve for angle B. And so I'm just going to start plugging things in. So 19 squared is equal to 8 squared plus 14 squared minus, I like to do this in parentheses, 2 times 8 times 14 times cosine of B. Okay, so 19 squared is 361 is equal to 64 plus 196 minus 2 times 8 times 14, so minus 224 cosine of B. Okay, I cannot subtract this from 224. This is all together. So that is the biggest mistake. That is what people make. That's where the biggest mistake is every time. So I have 260 minus 224 cosine of B. I cannot subtract this. I can subtract the 260 to the other side. So 361 minus 260 is 101 equals negative 224 times cosine of b. Now I can divide by negative 224. So 101 divided by negative 224, and I get some icky, gross decimal, right? 4508, blah, 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 equals cosine of b. So then the last thing would just be to take the cosine inverse, right? Take the cosine inverse of that. Again, you need to make sure that you're in degrees. So always double check that you're in degrees. So cosine inverse, that number, and I get that b is about 116.8 degrees. So I used the law of cosine to find b. Now that I know b, I can use the law of sines to find a or c, right? So let's do a. So now I can say that sine, and let me show you what I did here. So I did 101 divided by negative 224. And then I took the cosine inverse of that answer. And that's how I got this. I'm going to go ahead and store this under C. Oh, sorry, under B. This is B, not C. There we go. So now it's there. Okay. So now I'm going to take sine of my 116.8 divided by the side across from that, which is 19, equals sine of A over side A, which is 8. And we cross multiply, and I get that sine of A is equal to 8 times the sine of 116 over 19. And then you take the sine inverse of that, and that will get me A. So this is what it's going to look like on my calculator. So I have 8. And then I'm going to take the sine of B, and I'm going to divide it by 19. Then I'm going to take the sine inverse of that. And then, so I get the angle A is about 22.1 degrees. 22.1 degrees, more or less. Okay, and I can now save that under A. So go back to my calculator, and I'm going to store it under A. Now if I want to find C, I'm just going to do 180 minus A minus B, and I get 41.1-ish, right? So C is about 41.1 degrees. And there it is. So practicing using that law of cosines to find out our one side, and then once we know the one side, then we can use law of sines. So let's look at another one of those. Okay, so here it says in triangle ABC. Again, I like to draw it. Oops. Doesn't have to be perfect. Okay, so B is 9 meters, C is 12 meters, and angle A is 25. Find the remaining sides and angles. So I'm going to do A, right? I want to know all 6 of my angles and sides. There we go. And I know that A is 25. I know that B is 9 meters and C is 12 meters. Okay, So the question is, do I know an angle and the side across from the angle? And here the answer is no, I don't, right? Because I know my angle is 25, I don't know what the side across from that is. So because I don't have that, I have to use law of cosines. Because I have angle A, I'm going to go ahead and use my a squared equals b squared plus c squared minus 2bc times cosine of A. So I'm going to go ahead and use the first one because I know what angle A is. So this gives me a squared is equal to 9 squared plus 12 squared minus 2 times 9 times 12 times cosine of A. And then we just solve it, right? This is 81. This is 144 minus 2 times 9 times 12 is 216 times cosine of A, which is 25. And so I'm going to keep going, right? So I'm going to show you, and actually I can enter this into my calculator. So let's look at that. Okay, I'm going to clear it. So I have 81 plus 144 minus parenthesis 216 cosine of 25. Close your parentheses. So you can just enter the whole thing into your calculator as long as you're careful with these parentheses. I'm going to hit enter and I get 29.24, let's just say. So a squared is equal to 29.24. Now I have to take the square root of both sides. So I'm going to take the square root of my answer, hit enter, and I get 5.41-ish. And that's A. So I'm going to go ahead and save that as A. I'm going to store it as A. There it is. Now that I know A, 5.41 meters, I do know an angle and the side across from the angle. So now I can use law of sines to find either B or angle B or angle C. So we can take my sine of 25 over 5.41 equals, and let's just solve for B. Sine of B over 9. So I solve, and I get sine of B is equal to 9 sine of 25 divided by 5.41. I take the sine inverse of both sides, and let's see what we get for B. Okay, so I have, let's clear this, 9 times sine of 25 divided by, now instead of doing 5.41, I'm going to use the exact value, which I saved under A. So there's that. And then I'm going to take the sine inverse. Oops, I hit alpha. The sine inverse, there we go, of that. And I get 44.7. So B is about 44.7 degrees. And I can save that under B, or I can just do, right, 180 minus 25 minus my answer. And I get 110.3. And I've been able to find all the missing parts and pieces of this triangle. So a lot of the times with law of cosines, you have to do law of cosines, but then in order to keep going, you'll have to go back to the law of sines. So just keep that in mind that you can use both. Okay, let's look at an application problem. A pitcher's mound on a women's softball field is 43 feet from home plate, and the distance between the bases is 60 feet. Pitcher's mound is not halfway between home plate and second base. How far is the pitcher's mound from first base? Okay, so I'm going to go ahead and draw a field, more or less, right? And so here's the pitcher's mound. And this distance right here is 43. And this distance, I don't know. And this distance is 60. Okay, oh, and then the other thing is, I know that the pitcher's mound is directly splitting this. So this I know is 45 degrees, but I don't know about this guy. Okay. So again, I have all of these, I have an angle, side angle, or a side angle, excuse me. And the question is, do I know an angle and the side across from the angle? And the answer is no. So I cannot use law of sines. I have to use law of cosines. So that tells me that I'm going to have d squared, right? So d corresponds with the angle. So whatever side corresponds with the angle is always what's on the other side of the equation. So I have d squared equals 60 squared plus 43 squared minus 2 times 60 times 43 times cosine of my angle, which is 45. And we're just going to start solving. And you can enter even this into your calculator if I show you. So I can go 60 squared plus 43 squared minus 2 times 60 times 43 times cosine of 45. And then I close it all. So I get that d squared is equal to 1800 something 0.33. Right, so then I need to take the square root of that. And I get 42.43. So D is 42.43 feet. So the distance from home plate and second base, oh, sorry. Yeah, that's fine. Oh, how far is the pitcher's mound from first base? Wow, I read that wrong. Yep, so there it is, from first base is 42.43 feet. Let's look at another example. Okay, a ship leaves from point A and travels 60 miles due east, so straight east. Then adjusts its course northward, but not due north, at point B. After traveling 80 miles in the new direction, the ship is 139 miles from its point of departure at C. Describe the bearing from point B to point C. Okay, wow, lots of stuff going on. Let's just draw it, okay? So we have a ship, and it leaves point A, and it goes 60 miles directly east to point B. Then it goes north, but not due north. So it goes northward, like that, to C. And it travels 80 miles in this new direction. Right? And it is 100, oh boy, sorry. It is 139 miles from where it started. So that's 139 miles. I want to know the bearing. So if I draw my north-south axis, like so, I want to know, what is this? What is the bearing? Okay. So let's start with a few things. If I know all of angle B, I know that this is 90. So I would be able to find that. So let's find angle B. Okay, which means that I'm going to be using B squared is equal to A squared plus C squared minus 2AC times cosine of B. And I'm just going to start plugging numbers in. So B squared is 139, so 139 squared is equal to 80 squared plus 60 squared minus 2 times 80 times 60 times cosine of b. Okay, so 139 squared is 19,321. 80 squared is 6,400. And 60 squared is 3,600. Minus 2 times 80 times 60 is 9,600 times cosine of b. All right, so I'm going to subtract the 6,400 and the 3,600. So 19,321 minus the 6,400 minus another 3,600, and I get 9,321 equals negative 9,600 times cosine of b. Okay, we're going to divide by negative 9,600, which gets me negative 0.97-ish. So from here, I'm going to show you what I'm doing now on my calculator, okay? So I did 9,321 divided by negative 9,600. That got me this, okay? Now I need to just take the cosine inverse of that to get me b. Let's go back. So I'm going to take the cosine inverse of my answer, and I get 166.15. And I'm going to save this as b. So I get 166.15 degrees. So that's what b is. So let's look at this angle like really closely. All of b is 166.15. If I take out the 90 degrees, it'll tell me what's left, right? So if I do this minus 90 degrees, I get 76.15. So this right here is 76.15 because this is 90. 76.15 degrees. So then the last thing is I just need to describe the bearing. Well, I'm starting on the north axis, so it's north. And then I'm going 76.15 degrees to the right, which is the direction of east. So there is my bearing to go from B to C. Hopefully not too bad. Cross our fingers here. Last one of this type is a U-try. So I want you to read this again. Draw it if it helps you. 2 airplanes leave an airport at the same time on different runways. One flies directly north at 400 miles per hour. The other airplane flies on a bearing of north 75 degrees east at 350 miles per hour. How far apart will the planes be after 2 hours? So see if you can draw it and go ahead and give this a try. And then when you're ready to go over it, hit play and we'll go over it. Okay, so let's go through this again. I have 2 airplanes that left the airport, right? One goes straight north at 400 miles per hour. The other one flies at a bearing of north 75 degrees east. So that tells me this is 75 at 350 miles per hour. And how far apart will they be after 2 hours? So this one, if it's going 400 miles per hour, then it has gone a total of 800 miles. And then this one is going 350 miles per hour, so that's gone a total of 700 miles. And I want to know, how far apart are they? Just call it X, right? I want to know how far apart. So the question that I always ask, do I know the angle and the side across from the angle? And the answer is no, I don't. The only angle I know is 75, and I don't know the side across from it. So I have to use law of cosines. So that's going to give me x squared is equal to 800 squared plus 700 squared minus 2 times 800 times 700 times the cosine of my angle, which is 75. And again, this is something that I can just straight enter into my calculator. So let's go ahead and do that. Okay, so 800 squared plus 700 squared minus, and I always like to put this in parentheses, right? 2 times 800 times 700 times cosine of 75. Close it, enter. Boom, there it is. That's what x squared equals, right? So x squared, what was it, 840, 122.67. So then x is about, so all I have to do then is just take the square root of that number. So 916.58. So 916.58, and then what is the unit? Miles. The unit is miles. So these two planes are about 916 miles apart. And that's it. Okay. So hopefully lots of cosine, is making sense here. The last thing we're going to look at is Heron's formula. Now this one is nice and it's a different formula to find area, right? Last time the formula we used to find area required us to know an angle. Here on Heron's formula, you use this when you don't know any angles. So if you just know side, side, side. So if all you know is side, 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 you can use this formula to find the area of the triangle. Okay, and here it is right here. Area, where it's the square root of s, so the square root of s times s minus a, side a, right? Where s minus b, side b, and s minus c, where s is half the perimeter. So you just add up the three sides and divide by 2. So once you find s, then it's just plugging in numbers, and it should be pretty quick and easy. So we're going to do one together, and then you guys will do one on your own, and then we'll be done. So here it says, find the area of a triangle having side lengths of 43, 53, and 72. So the first thing I have to do is do 1/2, and then the perimeter. So 43 plus 53 plus 72. And that's something I can just enter into my calculator. Okay, and we get S is 84 meters. Okay, so now that I know what S is, I can find the area. Right, so it's going to be S, which is 84, times S minus A, so 84 minus 43, times S minus B, so 84 minus 53, times S minus C, so 84 minus 70. And again, even though the formula says ABC, if your triangle is labeled DEF, it's going to be the exact same thing. So just always be aware of how these formulas still work for triangles, even if they're not labeled ABC, right? All right, so this gets me 84 times 41 times 31 times 12. So that is what I'm going to enter into my graphing calculator. So 81 times 41 times 31 times 12. And then I'm going to take the square root of that. And I get oh, I did 81. That's why you guys have to yell. I'm like, that answer is not right. Not 81, it's 84. Here we, oh my goodness. There we go. This is what happens when you do this after surgery, right? And I get 1131.8 9-ish, let's say. So the area is equal to 1131 point, let's just say 89 meters squared. Don't forget your units, right? Your units needs to be squared because we are finding area. All right, last problem here is a U-try. It says a commercial piece of real estate is priced at $4.50 per square foot. Find the cost of a triangular lot measuring 320 feet by 510 feet by 410 feet. I need to find the area of this lot, and then whatever the area is, multiply it by the price. So go ahead and try Heron's formula. You can do it. Plug and chug, right? And then when you're ready to go over your work, hit play. Okay, so let's review it. Hopefully you started with finding S, right? Because I need to find the area. So S is 1/2 times 320 plus 510 plus 410. So hopefully we got that S was 620 feet. Once we know what S is, then we can go ahead and complete the problem, right? Where it's S, 620, times 620 minus 320, times 620 minus 510, times 620 minus 410. So when we enter this into your calculator, it should be 620 times 300 times 110 times 210. Holy moly, it's a large number. And hopefully we got that the area, well, let's just go ahead and do it. Okay, so 620 times 300 times 110 times 210. Big number, and then I take the square root of that. And that's my area, about 65,548 square feet. Okay, so area is about 65,548.46 feet squared. Okay, but I want to know the cost, right? How much is this going to cost? So the cost is equal to the area times $4.50. So I'm just going to take my area and I'm going to multiply it by $4.50. And that is my cost. So it's going to be about $294,968.05. Holy moly, that's an expensive piece of land. Okay, so that's it for 6-2. Hopefully we're feeling good about it. As always, reach out if you need anything, and we will see you in the next video.